Good morning. In this session, we will take a problem based on moving charges. We know that when a moving charge enters the magnetic field, it experiences a force, and depending upon the direction and the velocity, it will take different path. The direction of the charge, uh, the direction in which the charge moves, changes because of the force. Now take then this problem: an electron and a proton moving with the same speed enter the same magnetic field region. At right angles to the direction of the field. Find the ratio of the radii of the radii of the circular path which the particles may describe. Now you take down this figure also. This is the field going into the plane of the paper. Now proton and electron enter this field. Proton and electron enter the field in a direction perpendicular to the field P and E. Let me read this once. An electron and a proton moving with the same speed enter the same magnetic field region. So important to note, same speed, same magnetic field, and at right angles to the direction of the field. This means that after entering the field, the proton and electron follow a circular path. We need to find out what is the ratio of the radii of the circular paths. First we will write the given quantities. Given speed of proton is equal to the speed of the electron. So if I say Vp is the speed of proton, let Vp is the speed of proton and V is the speed of electron. Speed or velocity. we can write Bp is equal to Ve. So let us say they enter the magnetic field where B is the field intensity. Now let us say Rp is the radius of the circular path for the proton, and similarly Re is the radius of the circular path followed by the electron. Rp is the radius of the circular path for proton. Followed by the proton or made by the proton. R is the radius of the circular path followed by the electron. Now we know the radius is given by the formula for radius of the circular path is given by this. We derived in the last session. We have derived the radius of the circular path. So if R is the radius of the circular path, R, the radius of the circular path, it is given by mv by qb. This is the formula for radius of the circular path. The radius of the circular path is given by mv by qb. Now apply this equation for proton and electron. So now I can write for same speed and magnetic field. For Rp we can write as mass of proton, velocity of proton divided by Q, that is charge of proton, into the same field. Similarly the electron is mass of electron into velocity of electron divided by QB. Here charge of proton and charge of electron are equal, only they differ in sign. And then B, magnetic field is also same. Now take the ratio Rp by Re is equal to mp Vp divided by Qb whole divided by me Ve divided by Qb. Now few things cancel here, and given the velocity are equal, Vp is Ve, same speed, so I can cancel this also. Therefore I get Rp by Ra is equal to Rp by Re is equal to Me by Mp. Mp by Me, because radius is proportional to mass. Rp by Re is Mp by Me. This is the ratio of radii. Rp by Re is equal to Mp by Me. Or we can directly write, for same speed and same magnitude of the charge and same magnetic field, the radius is proportional to the mass. Rp by Re is Mp by Me, or Re by Rp is Me by Mp. Next, hope you understood this problem. We'll take another one. Second one. Write the relation for the force. Write the relation for the force F acting on a charge carrier Q. Force F acting on a charge Q moving with a velocity V through a magnetic field B in vector notation. Using this relation, deduce the condition under which this force will be maximum and minimum. Write the relation for the force F acting on a charge Q. Now I'll write these as vectors. That also you can make a note. F is a vector. Write the relation for the force F acting on a charge Q moving with velocity V. V is also a vector through a magnetic field B in vector notation. Using this relation, deduce the condition under which the force will be maximum and case number B minimum. Now we know the formula for this. F is Q into V cross B. In vector notation, we can write the force F as Q into V cross B. Force acting on a moving charge in magnetic field as Fs you can write it as a vector F is equal to Q into V cross B. This is in vector form, and write the vectors. F is a vector, V is a vector, B is a vector. Or magnitude of force is given by, or magnitude of force Fm is QVB sin theta. This is the force. Now for maximum force condition. First case is maximum. Maximum force. The force is maximum when sin theta becomes equal to 1. The condition for maximum force is sin theta equal to 1. Sin theta equal to 1, or theta is 90 degree. That means the angle between B and V is 90 degree. Therefore, F max can be written as F1 of maximum force is equal to QEB. Next is minimum. The condition for minimum force is sin theta equal to 0. Or theta equal to 0 or 180 degree. This is the case wherein the charge moves parallel or anti-parallel to the magnetic field. The force is maximum when they are perpendicular to each other. Therefore, we can write the force is maximum minimum F m minimum as 0. Minimum force is 0. These are the conditions for maximum and minimum force, and hope you understood this.